Complex fractions. A complex fraction has one or more fractions in the numerator or denominator. You can simplify complex fractions by rewriting the fractions as a division expression. So what we're looking at when we see a complex fraction is a fraction within the numerator or the denominator or both of a fraction. So you notice we have a fraction bar here with a numerator and denominator, and then those numerators and denominators are also made up of fractions. So at this point, what we can start to think about is this division bar, this fraction bar as division, and we can rewrite this fraction as a division problem, and those we know how to do. So let's take a look at this first one. I have g cubed h over b over gh cubed over b squared. So I'm going to split this up. I'm going to take my g cubed h over b and divide that by gh cubed over b squared. Since it's division and we don't divide with fractions, we're going to change that into multiplication. So I get g cubed h over b times b squared over gh cubed. So now from here we're going to simplify and look for common factors. So I've got a g here, and I can simplify that with my g cubed. That gives me g squared. I have an h cubed down here and an h, so that leaves me with h squared in my denominator. And my b squared I can simplify out, and that gives me a b. So that leaves me with g squared b in my numerator and just an h squared in my denominator. Done. All right, let's take a look at another one. Again, we're working with monomials at this point. So I have my negative 24m cubed t to the fifth over p squared h, which is over 16pm squared over 2 to the fourth h. So I'm going to split that up again into a division problem here. So I'm going to put my numerator divided by my denominator. Then I'm going to change this to multiplication by multiplying by the reciprocal. So I'm going to flip this over. And at this point, I'm going to look for common factors here. So my 16 and my negative 24 have a common factor of 8. This leaves me with a 2 here and a negative 3 in my numerator. Let's see, my m's I can factor out. So my m cubed and my m squared. This leaves me with just an m in my first numerator. I've got, let's see, what else? I've got my h and my h that I can simplify out, and I think that's it. Yep. So we have negative 3m t to the 9th power in my numerator, and we have 2p cubed in my denominator. Done. All right, let's take a look at some more complex fractions. Let's take a look at some that have polynomials in them. So I have x plus 4 over x minus 1 over x squared plus 6x plus 8 over 2x minus 2. So again, I'm going to split this up, and I've done this changing it to division and then multiplying by the reciprocal in one step here. So I'm going to take my x plus 4 over x minus 1 as my first number here, my first expression, and then my second expression, I've just automatically flipped it. So from here, since I'm working with polynomials, I want to factor everything. So these are binomials, so I'm kind of done with them. There's no GCF I can pull out. Here I can pull out a GCF of 2, and then my trinomial here I could factor. So I'm looking for common factors here, x plus 4 and x plus 4. Those are common factors, and I have an x minus 1 and an x minus 1 that I can simplify out also, which leaves me with 2 over x plus 2. Done. Again, we've talked about in this chapter, it's super heavy on factoring. So again, if your factoring skills are still not super strong, a little more practice, please. All right, and our last one, n squared plus 4n minus 21 over n squared minus 9n plus 18 over n squared plus 3n minus 28 over n squared minus 10n plus 24. So again, I'm going to take my numerator expression, write that first. I'm going to write this as multiplication, so I'm going to take my denominator here, my second expression, and automatically flip it over so that I have the reciprocal. I'm going to factor each of these. We have 4 trinomials here, so we have to do a lot of factoring, so I factored each of those. And now we're going to look for common factors, so the n plus 7s simplify out, the n minus 6s simplify out, these n minus 3 simplify out, and so do the n minus 4. So we'll end up here with 1. All of these have simplified out quite nicely. So taking a complex fraction, we're going to rewrite it as a division problem, change that to multiplication, simplify by looking for common factors, and then we're done.